Hello, welcome to Nomenclature. This is, I believe, part 3. And in this particular presentation on nomenclature, what we're going to look at is we're going to focus on the type 1 and 2 compounds again, except now we will look at when they are mixed, say on the same worksheet, where you may have 20 of them listed, and the first one you don't know if it's type 1 or 2, the second one you're not sure if it's type 1 or 2. So what do? How do you name it? How do you write the formula? So we're going to look at that in this particular presentation because naturally you would expect that when you have knowledge of how to name and write formulas of compounds, and then you're skipping through the book, you're looking through a website, and there are formulas, there are names there, that you should be able to recognize them. They're not going to label them for you. Oh, this is a type 1, or this is a type 2, etc. You just have to recognize them. So how do you do that? Well, this will be a relatively short presentation on exactly what to do. I do have the introductory material here, like the outline, type 1 and 2, etc. These slides have been presented earlier in the type 1 and 2 independent presentation, so I'm just showing you, and I'll skip over. Likewise, with the crisscrossing, I will simply skip over this, pause if necessary in order to review crisscrossing. Okay, here we are. When type 1 and 2 are mixed, say, on the same worksheet, what would you need to do? Well, to identify the type 1 from the type 2, you would want to go, say, from the name to the formula. Remember that type 2 names are very obvious and are very easy to pick out simply because they have a Roman numeral following the cation's name, or they have a Latin version of the cation's name. So if you have a name and you want to put the formula down for it, the difference between type 1 and 2 is pretty obvious. Now, going from the formula to the name backwards, if you will, in the reverse at least, it is not as easy. It's not real difficult, but it's just not as obvious, okay? So now, if you have them all memorized, which I'm strongly encourage you to memorize that ion list, if you do, then it becomes kind of self-evident. Oh, that's, Cr, it's chromium. That's, of course, a type 2 compound because it's variable. It has multiple charges. Oh, wait, that's sodium, Na. It only has one charge, so it is a type 1 compound. If you memorize these ions, it can be that easy. But if not, what do? Well, basically, if you want to go from the formula and name it correctly, it is necessary to know which type of compound it is, since it will directly affect how you name it. Remember that the cation is the clue that will control the system you use to name. Will it have a Roman numeral or not? Will you have a Latin version or not? That's really the decision. Well, here's a flow chart that I would like to say I developed, but I probably borrowed it from somewhere and modified it to fit our needs. So what does this say? Well, if you can follow this flow chart, this may very well help. So if you are presented with a formula and you want to name it, I go through these mental questions in order to decide is it a type 1 or 2, unless, of course, I have them ions memorized. So what do? The first thing I do is I ask myself the question when looking at a formula. Does this compound begin with a metal or with ammonium, NH4? Okay, so does it begin with a metal or ammonium? If the answer is yes, I have a second question that I ask myself. Does this metal have more than one possible charge? Well, if the answer to that question is yes, this compound is a type 2, and if I'm using the stock system of naming, I will need to have Roman numerals in the name in order to indicate the charge. If, however, the metal has only one possible charge, then the answer is, no to this question. Does the metal have more than one possible charge? The answer would be no. It's a type 1. Remember, with type 1 compounds, when you name them, it's just straight naming. The cation is named first with its full name, and the anion is named last, either with the IDE ending or, if it's a polyatomic ion, with its full name. No Roman numeral, no Latin, no prefix, no suffix, no anything. So There you go. This is a flow chart. Now, this actually would have a no answer to it. You know, does it begin with a metal or ammonium? And the answer could be no. But if the answer is no, that'll lead us to type 3 or type 4, and we're not there yet. So half of this flow chart is missing, and it's missing, of course, on purpose. Well, the best way to do this is simply just to look at some examples. And so being very close to the end of this presentation, because this is all we're going to do now, is let's look at these mixed examples. Plumbic hydroxide, rubidium oxide, ammonium oxalate, chromium 3 sulfate. The formulas NaNO3, the formula Mn parentheses SO4 2, AgCl, SnF4. So if I wanted to write the formula, so if you're given a name, you would want to write the formula for it. That is typically what the instructions are, especially in this chapter when we're focusing on that. So I would look and I would have to decide, is this a type 1 or 2 in order to come up with the formula? I would look at the next one, make that decision. Now remember, I can follow this flow chart. So does the compound begin with a metal or ammonium? Yes. Plumbic. Plumbic is lead. Lead is a metal. So the answer to this first question is yes. Then I need to ask myself the question, does lead have more than one possible charge? The answer is yes, it's a type 2. Now this is really going from a name, or excuse me, from a formula to a name, but it still works to some degree to decide this. Now I'll say though, when I looked at plumbic, that is clearly Latin to me. And because it's Latin, it had to be automatically type 2. But the flowchart works. The flowchart is much better for these bottom four, going from a formula to a name. So I look at the Na and I say, well, Na, does the compound begin with a metal or ammonium? Na is sodium. Yes, it is a metal. Does sodium, the metal, have more than one possible charge? No, it does not. So it's a type 1. So when I name this compound, there will be no Roman numeral and there will be no Latin possibility. It's just going to be straight naming. That's how this flowchart works very well, especially for formulas to names. But it can help you with a name. Okay, let's move on and see a little bit of handwritten example on how I decided. Okay, so here are the first four names. Plumbic hydroxide. Well, I looked at plumbic. Plumbic, right, is lead. Lead has multiple charges, so I would declare this type 2. Rubidium. Rubidium, and it doesn't matter what it's hooked to at the moment. I'm just looking at rubidium. Rubidium has only one charge, so therefore it's a type 1 compound. Ammonium is clearly a type 1 compound. And then chromium 3, it's very obvious to me that it's visual. There's the Roman numeral. The Roman numeral tells me in a name it is type 2. So there you go. Now what would you do then? Well, if you have to go through and actually then generate the formula, what I would do is this. Plumbic. Plumbic is lead, and plumbic is the higher of the two charges, and so that is lead 4. So here's my lead with the 4 plus charge. Hydroxide is OH with a negative 1 charge. I encourage you to memorize your polyatomic ions because it becomes much easier to just write this stuff down so you're not constantly looking things up. But back to this question. So I see that lead has a 4 positive and hydroxide has a 1 negative charge. They do not cancel, so I crisscross. And when I do, I come up with this formula, Pb, parentheses, OH, 4. The 4 is outside the parentheses because there are 4 hydroxide groups, not 4 hydrogens alone. And this formula cannot be reduced any further, so I am done. That is the final formula for plumbic hydroxide. I could repeat this process for the other 3 examples. Now, with plumbic, I had to figure that charge because I had to understand the Latin. It's lead, and plumbic is the higher of the 2 charges, and I had to then know what the higher charge is for lead. The Roman numerals are much simpler because this automatically tells you it's chromium 3. You don't have to worry about higher charge, lower charge, or how many charges chromium has. This is chromium with the 3 positive charge. So I do like the stock system infinitely better than the Latin simply because of the ease of use of that system. Okay, let's move on to the formulas. Okay, so now we're going to concentrate on these 4 formulas down here and naming them. And remember, this is where that flowchart really comes to play. It really super helps out. Okay, let's move on and take a look at a handwritten, just some notes on this one. Okay, so I look at NaNO3 and I'm concentrating on the Na, that's the cation. Sodium, Na, has only one charge. Therefore, this is a type 1 compound. Because it's a type 1 compound, it is straight naming. Cation first with its full name, anion last with the IDE, or if it's a polyatomic ion, name it with the full name of the polyatomic ion, which is what nitrate is. Looking down one, Mn. Mn is manganese. Manganese has multiple charges, so this is type 2. Therefore, in this name, I will need a Roman numeral after the word manganese to indicate what its charge is. I have subscript, so I can re-crisscross subscript, but I need to check the anion to make sure that the anion, the negative charge, is correct for that, for sulfate in this case. If it is, the manganese charge is correct. If sulfate is not, chances are you'll either have to double it or triple it to make it correct. And whatever you do to the negative charge to make it correct, you have to do it to the positive charge as well. Then you can name it with a Roman numeral. I do not believe there's a Latin system for manganese, but if there was, you could use that. Ag is silver. Silver has only one charge, and so therefore it's a type 1 compound, straight naming, cation first, full name, anion last. Then finally, Sn. Sn comes from stannum, by the way, but it's our name for it. Well, our name for it is tin, Tin, tin. So tin has multiple charges. Therefore, this is a type 2 compound, and I am going to have a Roman numeral in the word, or in the name rather, after the word tin. Or I could, of course, use Latin if I want to, or if the instructions ask me to. I have subscript. I can re-crisscross and verify if the anion is correct and the cation is also correct. Okay, well, with all of that being said, here are the final answers for all 8 of those examples, which then can lead you to a practice worksheet, which I will, of course, post in the classroom. And so plumbic hydroxide has the formula, and we verify that that, of course, agrees with what was on the previous slide. Rubidium oxide, Rb2O, it's rubidium has a positive 1 charge, oxygen 2 negative. I crisscross, there's the formula. Ammonium oxalate, NH4 2, C2O4. I don't need to leave the oxalate in parentheses because there is only one grouping or one unit of it. If you leave it in parentheses, it's perfectly fine. Just make sure there's no extra subscript outside the C2O4. You're golden at that point. So how did this work? Well, ammonium is a positive 1 charge. Oxalate is a 2 negative. They didn't cancel, so I crisscrossed. That's where that 2 came from. With chromium 3 sulfate, this would have been a 3 positive charge. That would have been a 2 negative charge. They didn't cancel, so I crisscrossed. That's where the 2 comes from here. A lot of people, caution, caution, and danger, danger, Will Robinson. A lot of people, when they see chromium 3, automatically put the 3 as subscript. That is incorrect. It'll never work. So please be careful. That is a pitfall of seeing the word chromium 3 or other things that are written with the Roman numerals. Now, going in the other direction from the formula back to the name, it is imperative to know the type because the name will be dictated by the type of compound it is. Going in the direction of the name to the formula, it is a little less critical if you know if it's a type 1 or 2 or 3 or 4 for that matter. But going from the formula to the name, it is absolutely necessary to know that. So with a type 1 compound, notice cation first, anion last, no Roman numeral, no Latin. In manganese and sulfate, well, it turns out this is manganese 4 sulfate. Roman numeral 4 written in parentheses. Where'd the 4 come from? Well, I don't see a 4 over here. If you re-crisscross, you're going to find that this becomes a negative 1 because that's a 1 down there, so crisscrosses to be a negative 1. Negative 1 is incorrect for sulfate. How do I know? Well, you can look it up, but if you have it memorized, and I'm on that wagon again, if you have it memorized, it would be automatically, oh, that's incorrect. So because it's a negative 1 up here and that's not correct, you'd have to double it to make it a negative 2, and that is correct. So when this 2 crisscrosses up to the manganese, you gotta double that one as well. So it's manganese 4. This is the only way that I know to catch the various compounds that have formulas that are in the reduced form. And if you don't check that negative charge, you often will not see that it has been reduced, and the name will come out incorrect. And the name manganese 2 sulfate is incorrect for this formula. So if you take manganese 2 sulfate and do its formula, what you end up with is simply MnSO4, no other subscript at all. And that is not what we're looking at on the screen. So you have to understand that, certainly all of this is important. And, is manganese 4 sulfate and manganese 2 sulfate very different? Well, consider this. Water is H2O. Hydrogen peroxide is H2O 2. Just by the addition of one extra oxygen, it's a very different compound. Water, you wash your hair with, you drink it all the time. And hydrogen peroxide, you wash your hair, you bleach it, you drink it, you get sick. So yeah, just anything different about a formula, it's a completely different compound. So this stuff really is important. You see the last two, how they worked out, the type 1 compound straight naming. This type 2 compound, fortunately, this one was not reduced. So when the 1 came up to make a -1 for the fluorine, when I re-crisscross, so -1, that's correct. So the 4 comes up to 10, and that's correct as well. Okay, this is the last slide. So hopefully short. But this is how type 1 and 2, when they're mixed, when you can sort them out and name them and write their formulas. And there will be practice, and certainly the test when all of this unit is over is that you'll have several compounds all written down. And if it's a formula, give me the name. If it's a name, give me the formula. And they will be all mixed up. And so it'll be critical for you to be able to actually come up and correctly name and write those formulas. This is one way that you can start sorting them out. We will certainly include the type 3 and 4 eventually, and then they will all be mixed. Thank you.